In Part 1, we show that NOAA policy underestimates gaps in NEXRAD coverage over eastern Pennsylvania. NOAA's 2020 report on gaps in NEXRAD radar coverage provides NEXRAD visibility at 10,000, 6,000, and 3,000 feet above ground level. We use Esri ArcGIS to project the 3,000-foot coverage into Google Earth. The National Weather Service maintains a record of tornadoes since 1950. We import these data to visualize lower altitude radar coverage. We start with terrain blockage for the NEXRAD at Dulles Airport. No beam blockage is blue and severe beam blockage is red. Zooming in, a 3D buildings layer shows the intersection of the NEXRAD beam with man-made structures and vegetation. Our Collada model shows a radar scan at 1/2 degree. Beam elevation is increased to 1 and then 1.5 degrees to clear terrain. This vertical cross-section shows a horizontal beam bearing 140 degrees. Note that half of the radar power is bore-sighted on the Dulles Tower in a 1-degree beam at 5,000 meters range. We use the half-degree beam centroid to define the lowest detection altitude. NOAA policy appears to use the lower half power point, where as little as 10% of the beam energy may be scattered by precipitation. We now construct a floor mosaic for the 5 radars bracketing the eastern Pennsylvania gap. Starting with Dulles Airport, we add State College, Pennsylvania, some minor blockage at Binghamton, New York, no blockage at Mount Holly, New Jersey, and Dover Air Force Base is clear. This 3D floor provides an easy-to-understand view of the radar floor for the collective radar system. Precipitation that is under the radar will likely go undetected. It appears that NOAA policy uses the bottom of the beam as a detection threshold. The Maddox thresholds for 3,000 feet are consistent with detection defined at the half power point. Direct tornado detection by radar is rare. Indirect detection includes rotation and debris fields. Using Weather Service data as a proxy, there are 845 tornadoes in the gap area since 1950. According to NOAA, 26% of these are likely to go undetected. Using the half power point, we maintain that a much larger number are under the radar.